Previously, we've talked about how to take Excel and insert a scatter plot and a trend line to do linear regression. However, Excel also has a tool pack that allows you to do this. And what we're going to do this time is use that tool pack to once again look at our relationship between GPA and starting salary. So whenever you have your data, again, I've already moved it over. Click on data, and on the right hand side you should see data analysis. If you don't see this in the analyze area, that means you need to add the data analysis tool pack. I've provided another video for you to go in and do that. Once you've done that, come back in, click on data analysis, choose regression, and again, once we get into our regression, we need to choose the Y range. And again, do not choose the header. We're trying to predict salary. So let's take all of our salary data. And then our Y range, our X range, sorry about that. The X range is all of this. Again, if you put in the header data, Excel is going to throw an error and tell you that it can't work with a non-numeric. So again, does not have the header data. Make sure you have a confidence interval of 95%. That goes back to statistics. There's another video that goes in and discusses this with you. But what we're trying to say is we want to be 95% confident with the statistical analysis that's going on here. Go ahead and add this to a different worksheet, and we can click OK. And from there, a new sheet pops up, and in the new sheet, it says, okay, here's our information. It's a little harder to pick out this time. However, Y equals, look in the bottom, here's the slope, 7.42x plus the intercept is 45.8. All right. Similarly, R squared value is 0.31. This looks almost, like within just fractions of a decimal point, the same as whenever we did it before. However, there's more information now. In particular, hopefully you remember back from statistics that whenever we're looking for a 95% confidence or a 95% on the confidence level, what we're trying to get is a p-value that is less than 0.05. That means that there's a 5% chance that the model that we just built is just due to the randomness of the model. And you can see the p-value here is 4.5 to the negative 0.26. That is significantly less than 0.05. So our model says that this intercept value, it's less than 0.05. So statistically, we know that this is a significant value. Similarly, on our slope, we are less than 0.05. So the model has extra information here. Again, we're checking it with the 0.05 value, which says, once again, there's less than a 5% chance that this is just due to randomness. The last thing that we wanted to do in this model was, if I wanted to predict what the salary would be based on a GPA of 3.1, I could take and type in here, if this is the slope and this is the intercept, slope of 7.42, intercept of 45.8. Here's my GPA. Here's the salary. What I want to multiply the slope times the GPA and then add the intercept. It says that if I'm a business student with a 3.31, I should expect about $70.4 thousand as my starting salary. All right. Again, that's from the data that we have here. Please don't think in your area that that's exactly what you would get in your area, but hopefully this gives you an idea of how to use the data analysis section of Excel to do a linear regression.